In this video, we will talk about probability topics. First, we're going to begin with terminology, because to understand the probability, you need to understand the terms that we use in probabilities. Then we'll talk about independent and mutual exclusive events. We will talk about the basic rules of probability. We will know how to build contingency tables and tree and Venn diagrams. So by the end of this chapter, you will be able to understand and use the terminology of probability. You will determine whether two events are mutually exclusive or they are independent. You will calculate probabilities using the basic rules that we learned and construct and interpret contingency tables and construct Venn diagrams and tree diagrams. Probability is the measure that is associated with how certain we are of outcomes of a particular experiment or activity. When we talk about experiment, we mean a planned operation carried out under controlled conditions. If the result is not predetermined, then the experiment is said to be a chance experiment. For example, flipping one fair coin twice is an example of an experiment. The result of an experiment is called an outcome. So if we flip a fair coin, then the outcome, heads or tails, is considered an outcome of an experiment. The sample space of an experiment is a set of all possible outcomes. There are three ways to represent sample space. The first way to represent a sample space is to list all possible outcomes. The second is to create a tree diagram and to create a Venn diagram. We use the uppercase letter S to denote the sample space. For example, flipping one coin will result in a sample space of H, T. H stands for heads and T stands for tails. An event is any combination of outcomes. We use uppercase letters to represent events. For example, the experiment to flip one fair coin. An event A might be getting at most one head. The probability of an event A is written as P of A, meaning the probability of event A. The probability of any outcome is the long-term relative frequency of that outcome. If you remember, when we created the relative frequency distributions, we said that the relative frequency distribution represents the proportion of the outcome, of each outcome or each category. So we can say that the probability, the percentage, the relative frequency, and the proportion are synonymous. Probabilities are between 0 and 1, inclusive of 0 and 1. The probability could be equal to 0, which means the event is never going to happen, or the probability will be equal to 1, which means the event will always happen, or we are certain that the event A is going to happen. If the probability was equal to 50% or 0.5 or 1/2, we say that the event A is equally likely to occur or not to occur. For example, flipping one fair coin repeatedly, let's say 100 times, the relative frequency of heads approaches 1/2, which is the theoretical probability of heads. Equally likely means that each outcome of an experiment occurs with equal probability. For example, if you toss one fair coin, then a head or a tail are equally likely to occur. Similar, if you answer a question on an exam, a true or false question, you are equally likely to select a correct answer or an incorrect answer if you're guessing. To calculate the probability of an event A, when all outcomes in the sample space are equally likely, we're going to count the outcomes for the event A and divide by the total number of outcomes in the sample space. And this is the theoretical approach to finding probabilities. For example, if you are going to toss two fair coins, let's say a dime and a nickel, then the sample space will look like this. Either we're going to get two heads, or a heads and a tail, or tails and a head, or tails and tails. In this case, because the coins are distinct, heads and tails is not the same as tails and heads. The sample space has 4 outcomes. Let's say that we have the event A, which is getting one head. Then the probability of getting one head, A, is going to equal how many outcomes in the sample space with a possible of only one head. We have 2 of them. out of how many possibilities in total. We have 4 possibilities. So the probability of getting 1 head is equal to 2 possibilities out of the 4 possibilities that we have. And this is the traditional way, or the theoretical way, to finding probabilities. This will lead us to the law of large numbers, which states that as the number of repetitions of an experiment is increased, the relative frequency obtained in the experiment tends to become closer and closer to the theoretical probability. Sometimes we need to know an or event or an and event. For example, an outcome is in the event A or B if the outcome is in A or B or in both of them. For example, if we have the event A to be 1, 2, 3, 4, 5, and the event B is 4, 5, 6, 7, 8, then A or B will be the combination of both of them. We're going to combine all of the events that happen in A and B without repetition. If you are dealing with an and event, an outcome is in the event A and B if the outcome is in both A and B at the same time. For example, if you have the previous events A and B, the event A and B is equal to 4 and 5, since 4 and 5 occur both in A and in B. Another concept that we need to understand is the complement concept. The complement of an event A is denoted by A prime, and we read it A prime. A prime consists of all outcomes that are not in A. Notice that the probability of A plus the probability of the complement of A is equal to 1. For example, if we have the sample space S is equal to 1 through 6, and A is the events 1, 2, 3, 4, then the complement of A prime, is 5 and 6. If we want to compute the probability of A, then we're going to count how many outcomes are in A and divide by the total number of outcomes. So we're going to get 4 over 6. If we want to compute the probability of the complement of A, then we're going to count how many events are in the complement of A. We divide by the total number of outcomes. We get 2 over 6.